Welcome to Chemistry Simplified. The topic for today is strong and weak bases. What are strong bases? Like strong acids, which we have seen previously, strong bases are expected to dissociate or dissolve or ionize completely when they are placed in water. They are also considered to be strong electrolytes, and the forward reaction is normally favored, meaning that if you were to place a strong base in solution, at the end of the reaction, you would mostly have products. Most of the reactants will be converted into products. Let's look at some of the strong bases. The first one is lithium hydroxide. Number 2, sodium hydroxide. Number 3, potassium hydroxide. Next, we have calcium hydroxide, strontium hydroxide, and lastly, we have barium hydroxide. So these are those strong bases. The first three, lithium hydroxide, sodium hydroxide, and potassium hydroxide, the metal that combined with the hydroxide is from group 1A. Remember from our first presentation when we looked at the periodic table, we call the group 1A alkaline metals. And the last three, calcium hydroxide, strontium hydroxide, and barium hydroxide, are from group 2A. Group 2A is referred to as alkaline earth metal. And the strong bases are not Bronsted-Lowry bases because they cannot accept proton or hydrogen ion. However, when they dissolve in water, for example, lithium hydroxide would produce lithium ion and hydroxide ion. The hydroxide ion, which is a base, can react as a base to receive a proton to produce water. But the strong bases on their own are not Bronsted-Lowry bases. They are Arrhenius bases. Remember, Arrhenius says that a base produces hydroxide ion in solution. So let's look at an example. Let's say we have sodium hydroxide, which is a strong base. It would ionize completely if it was placed in water to produce sodium ion and hydroxide ion. Sodium hydroxide dissociates completely in water as expected because it's a strong base. And sodium hydroxide, because it's a strong base, is also a strong electrolyte. And the forward reaction is favored, meaning that sodium hydroxide is expected to ionize completely to produce sodium ion and hydroxide ion in solution. Now we're done with strong bases. Let's look at the weak bases. So like weak bases produce only a few ions when they are placed in solution. They are weak electrolytes, and the reverse reaction is favored, meaning that at the end of the reaction, the weak bases will not ionize much. And any base that's not strong is considered to be weak. So, except for those 6 strong bases which we had discussed previously, any other bases would be considered to be weak. Let's add an example. Ammonia, which is a weak base, react with water. We have a small arrow to denote that the forward reaction is not favored. It produces ammonium ion plus hydroxide ion. And the reverse reaction is favored because it's a weak base. It does not ionize much in solution. So ammonia produces only a few ions in solution as expected because it's a weak base. And the reverse reaction is favored. As a weak base, it does not dissociate or ionize much in solution. Alright, this is the end of our presentation. Please remember to like, subscribe, and share, and comment below to let us know if you had found our presentation to be useful. Thank you. Bye bye.